I'm going to talk about Azure Verified Modules and best practices for Terraform on Azure. These best practices are best practice as per me, not Microsoft, right? So it's my personal opinions about stuff, but also from experience of working on it as well. It's unlikely I'm going to finish it, so sorry, I'm going to run out of time, but I'll try my best. So yeah, just a bit about me. So I work for Microsoft as a cloud solution architect, and one of my main roles at Microsoft is working with Azure Verified Modules. I'm a tech lead on the Terraform side and Azure Landing Zones. I build the modules for Terraform for Azure Landing Zones and the accelerators. And then I do a bunch of other Terraform stuff as well. I used to work at HashiCorp, which is the company that maintains Terraform, and I'm currently an ambassador for Terraform as well. But I'm telling you that not to show off, but just to let you know why I think I'm qualified to talk about best practices, I guess. Yeah, so I'm not just like doing it randomly. And also apologise to some people who are in this room who had to see this on Tuesday as well, because I'm doing it twice. And the reason that I'm doing it is because we haven't got enough speakers. So please. We need some speakers. Okay, so I'm going to do a quick intro to Azure Verified Modules first, in case anybody doesn't know about it. Does anybody not know about Azure Verified Modules in this room? Who has heard of it? Oh, okay. Well, okay, good. And then I've got a section on Terraform code, tips and tricks, which is kind of a deep dive into Terraform code. So I might leave that bit till the end. And I'll talk about the continuous delivery a bit first, in case I run out of time. Okay, so Azure Verified Modules, what are they? So, the first best practice in Terraform is don't write any code. That's what I'm telling you here. So use our modules instead, because we're going to write the code for you. And we've got a team of people at Microsoft who write the code. So all of these are modules that are written for Bicep and Terraform, and they're maintained by Microsoft full-time employees. They're all owned by a Microsoft full-time employee, at least one. They're aligned to the well-architected framework in terms of things like security and resiliency. So whereas you might use something in the provider, it might not be secure by default. It might have public networking open by default, for example. But in these modules, we'll turn that off, and if it supports availability zones, we'll turn availability zones on by default, that kind of thing. And we test for that as well. So we've got rigorous quality standards. We've got a whole bunch of specifications, which you can see on our website, around how these modules are structured, the quality of the code, the quality of the testing. And we test for against the well-architected framework standards as well. So we've got quite a lot of people using these modules already. We've got 13, well, this is a bit out of date, sorry, it's a couple of months out of date, this, because it was from an old deck, but about 13.6 million deployments so far, an average of 39,000 module deployments a day, and 15,000 Azure tenants that have used AVM so far, and about 43,000 subscriptions using AVM modules, and that's across Terraform and Bicep, not just Terraform. I know this is a bit small, so you probably can't see it, but there's 3 different types of module. There's resource module. That wraps an individual Azure resource, so like a storage account or a virtual network or a key vault, something like that, an individual resource. But it composes together things that might be always deployed alongside that resource. So things like diagnostic settings, private endpoints would also be included in that module as well, just to simplify things. And then, so we have a large set of those resource modules. And then pattern modules compose together one or many resource modules into an architectural pattern. So like an enterprise-grade Kubernetes cluster, Azure VMware service. We've just got an AI landing zone that we've just released last week as well. So they compose these modules together into something that's usable and production-ready, enterprise-grade, hopefully. The last one is utility modules. These are just things that are used inside pattern modules usually, or sometimes in resource modules, but they're just things like regions, so looking up Azure regions, IP addressing. There will be one for naming as well that we'll have soon. But they don't generally deploy anything, they just like provide data, basically. So that was an intro to Azure Verified Modules, just so you know what they are. Yeah, and like I say, if you've not looked at them already, it's worth a look because it could save you some effort, and we've got a whole team of people that are building them. Okay, so I'm going to jump past this bit and go on to the CI/CD bit. So again, apologies to everybody that's already seen this. So the first section is about module testing. So we're talking about shared module testing here. So if you're familiar with Terraform, this is the type of module that you would share inside your organization or publicly. It's a reusable module, as opposed to a root module, which is the thing that's actually associated with your state file in Terraform. So there's 3 different layers of testing that we're talking about here. So if you're familiar with software engineering, this is like the same layers of testing that you would find in like the testing pyramid. So unit testing, integration testing, and then end-to-end testing, which is a bit like functional testing. Unit testing, we do that with Terraform test. So built right into the Terraform CLI now, which has been for a few months, is a Terraform test capability. And that Terraform test has the capability to mock providers. So when you mock a provider, you just tell it what outputs you want on it, the same as if you were mocking a class in C# or something. And that means it's not going to deploy anything to Azure in this case, or AWS or GCP or wherever you're deploying to. It's just going to validate. You can just do like assertions on it that the logic in your module is giving you the results that you expect. So it's useful when you've got complex locals and things like that, where you're manipulating collections of data and things like that. You can get quick feedback that you've not broken anything, and also be able to test it. It does other things as well when you're doing that testing. It can do the preconditions and stuff like that in Terraform. But this is fast, cheap, because you're not deploying anything. The next layer down is the same tool, Terraform test, but this time you can use it with provider auth, and so you actually deploy something out to Azure, and then you can do your assertions on what comes back in the state file, basically, and say, yeah, it's deployed it in the configuration that I'm expecting it to. It's got the right settings and all that kind of stuff. So that's like the next layer down. And then end-to-end testing, which, because this wasn't really around when we started doing this, is we do this on every single module. We do this less so, more in complex scenarios. We do this type of testing at the moment, but we have it built into our CI/CD pipelines. So end-to-end testing is basically you writing the equivalent of a root module in Terraform that uses your module. So it might need some things like a resource group and things like that deploying. And then you actually deploy your module and deploy it out to Azure, make sure it works. In our case, we're testing for idempotency as well. So we want to make sure that if somebody runs another apply after the first apply, another plan after the first apply, that they're not going to get something changing unexpectedly. So we do a plan, we do an apply, we do another plan to check for idempotency, and then we do a destroy to make sure that works as well, and obviously to save costs. In terms of structuring this, I should have put a folder structure here, sorry, but basically we have all our modules in the root folder of the repository, and then we create a subfolder. In our case, it's called examples, because if you call it examples, you can also use that test in the Terraform registry. It'll show us an example in there, and then people can actually use that as a starting point for leveraging the module. And then inside that example folder, we have like one or many tests, like different scenarios. So we might have one with private networking, one with public networking, whatever it might be. So the way that we do that is this is like the example, and we've got a resource group here, and then we reference in our module, and basically we do this .. .. So whereas you might reference it from a Git repository or the Terraform registry or something, if you do this, it's just going to reference in a local file system, so you can just test it locally. So you can test it on your local machine or in CI/CD or anything. It doesn't need to go up to a registry first. And the last thing, it's not really officially testing, but for us it is part of our testing, right? Policies, code, and linting. So we use TF-lint, and we've got some custom rules in there as well to check for our styles and everything that we're expecting. And then we use OPA policies in the Rego language to test for things like well-architected framework, compliance, and that kind of stuff. And these run against every pull request. We can choose whether or not to run this, because obviously it's expensive and then sometimes can be a long operation. And if you're just making a one-character change, then the module owner can make the decision to not do that. But everything else is going to run. So the policies, code, and linting always runs. So we everything that we do in AVM is open source, and you can find it in the Azure repositories and steal it if you want to. Same with the actual modules themselves. They're all open source, so even if you didn't use our modules, you could steal the code from it and make your own module. So I've talked about testing shared modules, like reusable modules that you might publish to a registry, but what about the root module? Again, this is my opinion, right, and the opinion of my team, but root modules, they should be consuming your tested shared modules most of the time, so you don't really need to retest it doing all those different types of tests that I just showed you. And then the root module should still have the policy as code in place, so checking for things like increases in cost or the security things that you want to check for. It's that belt and braces, I think, is still valuable. But actually, like writing unit tests and stuff for a root module, because there's going to be so many of them with different things, I think it's not always that valuable personally. And then the thing that you do want to check is the plan, right? The Terraform plan. So, and you want to generate that Terraform plan as early on in the process as possible. And I would recommend doing it at pull request time. So, at pull request, you can generate a plan against your production environment using a read-only identity, and validate that plan is what you're expecting. It's not going to destroy your whole infrastructure or anything crazy like that, right? And you can do that before you've even merged any code, right? Because you're doing it right back in the pull request. So that is what I'd recommend. If anybody does have questions, feel free to ask, otherwise I'll just carry on. So yeah, identity. There's two different types of secrets or credentials that we might care about in infrastructure as code. One is deploy time secrets, and the other is runtime secrets. So deploy time secret is a secret that you need to actually run a Terraform apply, in our case, or a bicep deployment. And that is going to give you access to deploy resources into Azure, basically, or GCP or AWS, whatever it might be. A runtime secret is something that's needed by your application all the time. So it might be like a database connection string, that kind of thing, that is constantly needed by that application after it's been deployed. So this is what we really care about in IAC, is the deploy time secrets. In Azure, and it's similar in other cloud providers as well. There are different ways that you can authenticate Terraform or Bicep. So this score here is just something I've made up called a zero trust score, but you don't want to be in the red, basically, in my opinion. So a static secret, that you would know that as a client secret if you're using app registrations or a service principal. And a certificate, that's a big no, right? Because those are static secrets, and you've got to work out a way to rotate those. So I would strongly suggest that you do not ever use those, because it's just bad practice, and there's alternatives that are much better. A sort of halfway house is if you've got a product like Vault or CyberArk, Conjure, or something like that, you can potentially generate an ephemeral secret that's only valid for the duration of your pipeline run. And that is a capability in the Vault secrets engine, for example. I've put an orange tick because you've still got a secret there that could get out into logs and stuff, and you're better to have no secret at all, in my opinion. Down at the bottom here, we've got a compute attached managed identity. So if you're familiar with managed identities, you can have a user assigned managed identity or a system assigned managed identity, and that would need to be attached to the agent that you're running. So that means that that agent would have to be running in Azure in this scenario here. You couldn't run it anywhere else. That's better than these, because you've not got a secret to care about. But usually when people are deploying agents, they're not going to deploy one agent for every single workload they're doing. And even if you use user-assigned managed identities, and each one of those user-assigned managed identities has a different set of permissions, if you attach those all to the same compute instance, basically it's pointless. It's got access to everything. So I would suggest not doing that unless you really need to. So the one that you should be doing is OpenID Connect, which is also known as Workload Identity Federation in Azure and in other things as well. You can do that with an app registration or service principal in Entra, and you can do it with a user-assigned managed identity. So I've just said that a managed identity is attached to a compute instance, but there's two use cases for a managed identity. One is attaching it to a compute instance and use it as an identity. The other is for this OIDC use case. So you can create a user-assigned managed identity, create federated credentials on it, and then you can authenticate in a pipeline or whatever. So with OpenID Connect, Workload Identity Federation, you basically build a trust between, if you're using Azure DevOps or GitHub or GitLab or whatever it might be, you build that trust in advance, and then that gives it the capability to get an access token. Yeah.
Sorry, I didn't want to interrupt. It was just a question actually about the self-hosted agents. We can come back to that if you want to carry on about that.
So go.
How would you rank if you hosted an agent in your own on-premise hardware or somewhere else, AWS, wherever, and then used Arc to give it a managed identity in Azure that could then authenticate?
I think, well,
would it be more or less secure, I guess, is kind of my thought.
Similar, I think, similar scenario. Like if you've still got one agent and it's got, if you're trying to like use one agent to deploy everything in your organization or just a subset, those agents are going to have quite a large blast radius in terms of the permissions that they've got granted to them. That's what I'm trying to say.
Yeah,
you could have like thousands of agents, one for every single pipeline, which would be secure, but it would be very expensive, potentially. Okay. So my preference out of these two is a user-assigned managed identity. The reason being, you don't need any Entra ID permissions to create one. And it can be managed alongside everything else in your application landing zone. So when you vend a subscription, you can vend the identities you need to deploy the stuff into it. And then when you eventually retire that, you can destroy that at the same time, right? So you're not got loads of these hanging around in Entra that nobody's looking after. And the other advantage of this is it can get a longer access token. So if you've got something that runs for over an hour, this might work better for you as well. So this is basically what happens, right? So in Azure DevOps or GitHub, there's a concept of an ID token, which has subject claims, that things like I'm running in this repository context or I'm running in this environment context. You can get that ID token, and then you send that over to Entra ID, it should say there, but this diagram hasn't been updated where I stole it from. And then that'll basically go back to GitHub or Azure DevOps and say, is this a valid ID token? And yeah, it is. And then what are the claims? Do they match the claims that I've got for my user-assigned managed identity or my app registration? If so, it'll issue an access token, and that's just a standard access token as you would use anywhere else in Azure. The thing here is that there's no secrets, right? We're not passing any secrets around here. I'm trying to talk fast, sorry, because I was trying to get through as much as I can. So I wouldn't normally talk quite this fast. But, I'm not going to go into this, but if you want to set it for GitHub, these are the like types of settings you have to do. If you want to set it up for Azure DevOps, it's similar, but it's linked to a service connection in Azure DevOps, so it's a bit different the way it's scoped. You can do it with GitHub. You can have any subject claims. You can have things like what template it's running from and things like that. And then you can have, so in your federated credentials, you can say it can only run in the context of this template. With Azure DevOps, you can't do that because it's just a service connection. But you can put checks and balance. You can do approvals and checks on the service connection itself to control those things. And I'll probably talk about that more in a minute. I've already shared these slides, but I will share them again afterwards to this group as well. So you don't have to write all this down now. Okay. So another thing we do and recommend to certain customers, it doesn't suit every customer, is a concept of governed pipelines. So what do I mean by that? So I've mentioned this already a little bit, but requiring a specific template. So in GitHub and Azure DevOps, there's a concept of templates. You can build your pipeline based off reusable templates. You can specify that in order to use this identity, you have to use this template. You can do that in both systems, basically. What that does is it gives you control over what that identity can be used for. So in your template, you could just say, all you can do is plan or apply Terraform. You can't do anything else with that identity. So you get like a bit of extra protection around what people are doing with those identities. They can't do something you don't expect, like running a CLI command or something like that, right? So obviously there's ways around that with provisions and stuff, but let's not talk about that. But yeah, basically that's what it is, and we refer to that as governed pipelines. But it's just that extra layer of protection around what people can do with the identity that you're giving them. So. Approval gates. So this one is, should you have one, is the question. So should you have an approval between your plan and your apply in your production environment, like a human approval? Who thinks you should? Yeah. Okay, I only got one hand up then, which surprised me. But yeah, you should, right? You don't want to be pushing stuff to production and not have somebody's eyes on the plan first. It like as good as AI or some kind of analysis of the plan is, it's not going to be as good as somebody looking at it and just giving it that belt and braces check before you destroy your whole production environment. You do want to have an approval. And there's different ways to do that depending on whether you're using Azure DevOps or GitHub, and there's different places you can do it as well. So the two most common places that I see these approvals is, the most common is a multi-stage pipeline, right? So you'd have one stage of your pipeline for the plan, and then you'd have another stage of your pipeline for the apply, and there will be an artifact generated of your plan in between those two things. And then the approval would be on the apply, basically. And I'm only saying that you need this for like maybe for pre-prod, but certainly for production. For a dev environment, you don't need an approval, right? Because you're just going to slow everybody down. But for GitHub, the approval has to be on the environment, and for Azure DevOps, the approval can be right on the service connection. That's where I recommend putting it. So Azure DevOps has a concept of environments and like libraries and agent pools that can all have an approval on them, but the place to put your approval is on the service connection, because that's the thing that's wrapped around your identity, and that's what you're giving people access to on that approval.
Sorry, a really specific question. Are there any good tools you could recommend for exposing the plan in the actual GUI, or do you have to just go into the stage and look at it?
Yeah. So right now, I would say no, and I do have some examples of like spitting out like, is this going to destroy stuff or not with like a PowerShell script. But I am working because I work on the Azure DevOps task for Terraform. We're working on spitting out like a structured plan in that, which will give you like a nice graphical view right in the pipeline. So I'm working on that with a team at the moment. But because we're bringing it in from another task, because we're merging two tasks together. Yeah. Yeah. So yeah, we are looking at doing that. It's just taking a bit of time because it's not got to the top of the list. And so yeah, but you can. It's fairly easy. You can spit out a plan as JSON and then just like write a loop on it and pass it and say, is it going to? Do I care about this? Because is it going to destroy anything, or is it not? Like kind of thing. Yeah.
If you are doing the structured plan of thing, please add color to that one.
Yeah. No, it won't. So it won't be just the full plan spat out. It'll be something that's like folded up and nicer. Like then it's not just going to spit out. There'll be an option to do that, but we want to make it so it only shows you the things you should care about, the things that are changing, rather than like the whole thing. Yeah. The other place I see people doing this is PR approval. So when I mentioned before about generating a plan against production in your pull request, a pull request essentially has got an approval mechanism in it already, right? People are always approving pull requests. So you can also use that approval to say, yeah, I'm happy that this plan against my production environment is what is good to go. So by approving the pull request, they then actually deploy after that using the same plan that they generated in the pull request. So they save that as an artifact, and then use that artifact, that plan to do the apply. It's obviously a bit more complicated to set up, but I have seen people doing this, and it does work for them. And that means they don't have to implement a separate approval process. But, yeah. Okay. I'm not going to go into depth in here. Like I said, I'll share it. So we've already talked a bit about identities and things like that, but least privilege on these identities as well. So the first thing here is that I would recommend is using a separate identity for the plan and the apply stage. So when you're running a plan, you do not need write access to your environment. So don't give it write access to your environment. Make it a read-only identity. and then the apply identity would be the thing that's got read-write access. So when you're approving on that apply stage in your pipeline, you're also approving write access to that identity as well, basically. When you're setting this up, when you're bootstrapping your environments, like if you're vending a subscription or whatever you're doing to set up your environment ready to do continuous delivery with IAC, automate it, right? So the user identities, everything should be automated, and I would recommend using Terraform to do that as well because it works really well for it. But yeah, bootstrapping, automate it, because if you're doing stuff manually through the portal or running scripts manually, at some point somebody's going to make a mistake, right? So having automation in place really makes it that you're not going to make mistakes with these identities and the permissions that they've got and things like that. I'm just repeating myself here, but use workload identity federation. Don't look at using anything else, just use that. Only grant access in your state file, wherever you're storing your state, assuming you're using blob storage or S3 or whatever. Only grant access to the container it needs. Don't grant access to the full storage account. Just grant access to the container, right? You need to reduce the blast radius as much as possible. And also only grant access to the subscription or the resource group that it needs access to. Don't grant access to your whole Azure environment and enter and all that really when it doesn't need it. Just only the things that it needs to be able to deploy into. And I'd also, in Azure we have built-in role definitions like contributor and owner and user access administrator. I would consider, depending on your scale and how secure you want to be, creating custom role definitions as well, because those things like contributor and owner have got bigger than they need to be for most use cases. But obviously there's an overhead to doing that, so I'm not going to say definitely have to do that, but consider it. And then never. This is about users like people. Don't grant standing write access to a user account. So all of the user accounts in your organization, you need to use privileged identity management or something like that. And they should actually never really need write access unless there's some kind of break glass, the world is ending scenario, like an emergency. So by default, only grant read access. Nobody should be going in through the portal and making changes. It depends on maturity, obviously, right? But if you're going all in on the IAC, then there should be no reason for those users to have that standing write access. What was that edge case there? Sorry. Okay, so just ignore that for now. But what that was is, because I said at the top here, your plan identity only has read access, but the problem with that is if you're doing a data plane operation on a key vault, like putting a key into a key vault, when you run your plan, it's going to grant access to the identity that you're running to the key vault, assuming that's what you're trying to do. Because when you create the key vault, you'll have to give the identity that's running Terraform access to the key vault to be able to create a key in it, or the same if you're doing like a data plane operation on a storage account. The problem with that is if you're using one identity for plan and a different one for apply, it's going to try to grant the access to the plan, and then your apply one's not actually going to get the access. So obviously you can just feed in the ID of the apply one instead, but it's just a bit of an edge case to be aware of. Okay. Okay. So this is very Azure centric. There are other ways of storing state like HCP, Terraform, and things like that. But if you're using Azure, we've got some recommendations around it. So I'm not going to go too much into depth here, but basically the most granular approach is the best one. In terms of tiering it, this is what we recommend for Azure landing zones, is a three-layered approach. So the platform landing zone itself, so like your hub networking, management groups, what have you, one storage account with one or maybe a few state files to manage everything that's in your platform landing zone. Application landing zone bending, so the thing that creates your subscriptions and like peers of VNets and stuff like that to your platform landing zone, that's another storage account. probably central, but that would have like one state file per vended subscription or application landing zone. The reason there's a state file per is because otherwise you'll have like a problem with linear scalability, because if you're trying to manage all your subscriptions in one state file, it's going to take longer and longer, and the blast radius of a mistake in that is going to be huge. So definitely don't do that. So state file per subscription at least. And then for the actual application workloads, when you vend your application landing zone and your subscription and everything, vend a storage account at the same time into that subscription. We recommend a subscription per workload per environment. So there'll be a subscription for dev, test, and prod, however you structure it. So each of those would have its own storage account for its state in there. And then depending on what the app team are doing, they can decide how many state files they need for their application. But that would be on them to decide that then. Okay. Storage account security. So for the storage account itself, you want to be ideally using private networking, so not have it open to the public internet. Although, if you looked at, I forgot to talk about runtime secrets, but basically, don't have runtime secrets, use a managed identity. If you have to have a runtime secret, try not to let it get into your state file in Terraform. So ideally, there wouldn't be anything sensitive in your state file, but I would still recommend not exposing it to the public internet if you don't have to. Yeah.
The challenge often comes up, especially if you're using like GitHub hosting agents.
Yeah.
If they haven't got access to your private network.
Yeah. So
a lot of the time, I'm thinking more it's like bootstrapping really, the bootstrapping stage, rather.
Yeah.
You know, we sometimes do rule automation to allow the IP or something, but it's funny because they come out.
Yeah. So in the bootstrapping examples we've got, we put a private endpoint and put the agent. We do a self-hosted agent on a VNet basically. But there's other options like managed DevOps pools, if you're familiar with that, which can be injected into a VNet, and it will be available for GitHub at some point. But also, in terms of being able to access your resources on Azure, most of the time with infrastructure as code, you just need to talk to the management API, and which is a public thing anyway. But so there's a balance to be had. But I would recommend private networking is probably like the best practice approach. But there might be some cases where you just think it's too much hassle for what I'm doing. I don't know. But and then restrict access at the container level. So we're talking about the storage account container here. If you're familiar with storage accounts in Azure, don't grant the access at the storage account. It doesn't need any access there. It just needs storage blob data contributor at the container. That's the all it needs. It doesn't need anything more than that. And then definitely use Enter ID authentication. So when you look at by default, for whatever reason, it uses an access. I forgot what you call it now, but it's like an access token thing that it tries to create on the key vault, and that's just use Azure AD Auth instead. In the examples that I share, it uses Azure AD Auth, which is Enter ID authentication.
That's another question about
yeah. Say that again?
I'm the one firing the question.
No, it's okay. Yeah.
Encryption. So OpenTofu now supports encryption of state in storage accounts.
Yeah.
Debate because storage accounts encrypt anyway.
Yeah.
What's your view on that and whether Terraform should support state?
Encryption at rest. I mean, you would, why not if you can do it? But the difference between Terraform and OpenTofu is Terraform now has a concept of ephemeral resources and write only. I don't know if you've heard of that. But ephemeral resources they only are available in memory and they just write. And the same with write only things. So you can write a password, but it'll never be stored in the state and it'll never be shown in the logs. So and then it can track. There's the secret and there's a secret version that you need to use when it's write only. So you can track when you're changing it via that secret version, basically. But that's the way that it's done in Terraform.
Keep your secrets out of state.
Do not put secrets in state. But and now there's a way to do it, albeit it needs to be developed into the provider, the ephemeral and write only. I'm going to have to finish, sorry, because we need to get out of here at 8 o'clock. So sorry, I failed to finish this again. But I will share the deck afterwards. So if you want to have a look at it and ask me any questions or invite me to come and talk to you, I'm happy to do that as well. So, okay, thank you everybody. Okay.